Hello and welcome to another episode of the Oxford Online Maths Club. My name is James. I'm joining you today from the new studio. The new studio is actually my office. We're finally broadcasting live from actually in Oxford. This is really exciting for me to be actually doing this from Oxford rather than near Oxford, which is what it's been for the last couple of years. And it's really exciting to have proper internet connection for a change. I hope you're receiving this and it's not as bad as it was last week. Last week was so embarrassing that we moved to an entirely new studio. Hi to Harriet, hi to Ali, hi to Casey in chat, hi to Alfie. Hello to people joining us. Hi to Prisma, who's moderating chat today. Prisma is one of our current students who's helping out with the live chat. If you want to join the live chat, there is a Vvox code at the bottom of the screen over there. It is currently working. Oh yeah, and I'm wearing my lanyard because otherwise, in the office, otherwise I lose my access card because I'm very forgetful. Hi Harry as well. Hi everyone, look at this. Also, blast from the past, I've got a coming up slide. Do you remember those? We haven't had one of those in ages. Good, right, okay. We're gonna let people come through. We're gonna do some Vvox polls today, I think. I'm gonna try and get people to join in. You're gonna get a choice as the hive mind of chat to work out what you want to do in a game. Hi to Catherine as well, hi to Ali. And brilliant, I'm loud and clear, oh, amazing. We're gonna play a game and there's gonna be some sort of hive mind chat versus me sort of thing going on. So that's coming up today. Coins, we're gonna play a game involving coin flipping. Yeah, there are polls in, there's gonna be polls in Vvox, we're gonna make it work. And later on maybe cards as well. I'd like to talk about some problems with cards if there's time at the end there. Also trying out some stuff in the new studio to see if I can do things a little bit differently in here. If anything goes wrong, let's blame the new studio, not me. I'm calling it a studio, it makes it feel more like a professional live stream. Okay, if you're joining us for the first time, it's not always like this. Well, let's find out. Maybe it is always like this. Someone last week said it wouldn't be Oxford Online Maths Club without some technical problems, and that was so embarrassing that we've changed everything we do. Okay, here's the plan. I'm going to switch to this camera, and we're going to see what happens. Did it just end for anyone else? Have we gone down? Are we down? We up? We down? Oh, right, we're going to wait a minute because that's a very scary message. I'm going to try switching cameras at the same time. Obviously try switching cameras. That's obviously the best thing to do when your streams may be broken. I'm possibly talking to nobody. No, okay, nobody. Somebody else is still here. Like, fine here. Okay, right. One person's going to reload their YouTube and see if that fixes something for them. Okay, here's the game. We're going to toss a coin lots of times. I've brought a coin with me. Is that big enough if I write like that? Okay, so we're going to toss a coin and looking for a sequence of three outcomes. Looking for sequence of length 3, like heads, tails, tails. Now we're going to get a choice about what that sequence is. Quick question for chat. How many sequences of length 3 are there? I'm using H for heads and T for tails, just because this is an international live stream. This is what coins look like in the UK, I guess. Is this helpful for anyone? We've got a nice picture of the Queen on one side, and we've got abstract symbols on the other, which is referred to as tails, even though well, this isn't an animal with a tail. This is some leaves or something. Okay, so heads or tails are the things that people have on coins. Is that worldwide? Yes, okay. People are asking my question in chat, there we go. Lots of anonymous people, of course, because it's quicker to not put your name on it. So people put 8. I like that someone put 2 to the power of 3, which is also an explanation of how many outcomes, how many sequences of length 3 there are, like this one. Okay, 8 things. So here's how it's going to work. You're going to choose a sequence, and so am I. And whoever's sequence comes up first wins. Okay? So we're just going to toss some coins. All these sequences, I should say, on the first 3 coin flips, all of these sequences could come up, right? If you pick heads, tails, tails, that could come up as the first 3 flips. Anything you like, they're all equally likely for the first 3 flips. But after that, who can say? Right, let's turn on a poll. You're going to pick first, so please could you vote in, oh my word, let's see if we can get Vvox to work as well. There we go, here are the options. There are 8 possibilities. So, oh, people in chat, so someone's typed HHT as a chat message. Can we see the results live? Maybe nobody's voted yet. I'm going to work out Vvox. I hope this makes sense. We're going to flip the coins until one of these sequences come up, which will keep going until either your sequence or my sequence comes up. Oh, comments as well behind. The classic problem of not being able to show a poll and a Q&A at the same time. Ah, there is some voting happening. There is some voting, let's see. People are still voting, so I'm going to let you vote. One thing is currently winning by quite a bit, but I'm not sure if you can see which one it is. Oh dear. Mighty. Back on Slido, there was a button for this. I shouldn't talk about Slido, it makes people sad. Let's have a look. It's Q&A, how's it going? Somebody in chat has said they've seen this on TikTok, which is very exciting news, I suppose. I'm not on TikTok at the moment, so I haven't seen what's going on there. Prisma in chat is on TikTok and says that TikTok math is cool. So, homework for me, get on TikTok, James. Right, okay, let's look at results. Let's see what chat's picked. Show results. Okay, chat, I think you've picked fairly conclusive there. I think you've picked 1, 2, 3, 4, 5, 6, 7, 8. I think you've picked heads, tails, heads. Okay, brilliant. And I'm going to pick heads, heads, tails. Okay, so that's my sequence, and that's yours. Cool. How do we turn this off? Turn that off. There we go. Oh, somebody's finished A-level maths. Oh, we'll catch up with chat quickly. Raphael's just finished A-level maths. Hey, good stuff. And I'm getting recommendations for TikTok. One of the recommendations is that I do a TikTok, or Maths Club does a TikTok. So I was hoping for recommendations of existing TikToks. Right, okay, we've got to flip some coins. I don't know how long this is going to take. Sort of side homework question. Possibly doesn't fit in a TikTok video. Before I start flipping this coin, how many coin flips do you think it's going to take for one of these sequences to come up? But that question's quite hard. Okay, I'm going to toss the coin. There's a little bit of trust here. You have to trust that I'm not skillful enough to fix the coin flips, but let's go. Okay, so that's the first one. That is heads. So we're off to a good start for both of us. Heads is a very exciting thing to come up because both of our sequences start with heads. Second coin flip. Oh, it's going to look suspicious if it's heads again. It is heads again, I'm afraid. The second coin flip. Oh, ha, ha, ha. I'm feeling good about this one. I'm feeling good at the moment. And third coin flip is, this is going to look a bit fixed. That was a tails. Now, I think that is possibly the most suspicious thing that could possibly happen. So you have to decide a little bit. Oh my word. Maybe I can cheat. If you answered the question, how long do you think it's going to take for one of these sequences to come up with exactly 3 coin flips and James will win, then you might have been correct. Let's play again. Maybe this was rigged. So let's put James wins. We've talked about cheating, says someone in chat. Oh no. Let's try again and see if something honest might happen this time. That is heads. Oh no. Oh no. Oh no. Oh no. James just blue peated us. I've got heads again. This is. Imagine being unable to not cheat. Please not tails. Yes, perfect. Heads. See, I'm not cheating. I'm not cheating this time, am I? My sequence is completely wrong then. So somebody else's pick of what might come up. You can, I guess, play at the same time again. It's heads again. So we're still going. I should say we look at consecutive things coming up here. So this has got heads, 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 and then heads, heads, heads coming up over here. So 3 consecutive things. Somebody in chat thinks that it's looking pretty good for me. You think so? Think I must win now? Aha! Why do I win now? I'm still flipping. We're not done yet. But why do I win now? So someone says if we consider that none of the sequences repeat, then it takes 24 flips. That's one way of looking at it. Of course, with these 2 sequences that I've got here that we've picked, I could keep flipping heads for quite a while, keep flipping heads for quite a while, in which case it will take more than 24 flips. There are only 2 end conditions in any particular game. Yeah, so my opponent needs, you need heads, tails, heads. So you're waiting for a tails and then another thing to happen, whereas I win as soon as this tails comes up. Okay, well maybe I'm getting lucky here because both of these sequences that we've had so far started heads. See what will happen if it starts off with a tail. And now some cheating happens. Yes, okay, good, right. So there's a sort of analysis thing we could do here. Do I win every time? I probably don't win every time, right? Because if the first 3 flips are heads, tails, heads, then you win straight away. That could happen. That has probability, if we're talking about probabilities, 1 in 8, 1/8, because you need to get the head, then the tail, then the head. They're independent coin flips, each have probability 1/2 to come up the way you want them to. So you have a 1/8 probability to win sort of straight away. That's not your only way to win, but it is one way to win. I have a corresponding 1/8 probability to win from getting mine straight away as well. But then there's something else going on afterwards to do with how we can do things slightly differently later on. Shall we try again? Maybe now that you've seen that if you pick heads, tails, heads, then I've got this sequence which I think is better. I think that this wins most of the time. Actually, before we play again, let's bring some code in, because it wouldn't be the Oxford Online Maths Club without some slightly dodgily written code. Let's see if I can get this working. So we could keep playing. I wrote some slightly wonky code to try and show you what it looks like if we do this lots of times. So slightly dodgy code incoming, here we go. The way this works is it's going to try flipping coins, and it's going to redo the game 100 times and count who wins. So here it goes, it's drawing them on the screen. Look, here are the sequences of heads and tails, and there's some random stuff going on in there. Oh, did I put in the correct sequences? No, I did not. This was a practice run with the wrong sequences in. Let's see. So you picked that one, and I picked heads, tails. Excuse me, sorry. I need to actually tell it what chat actually did. There we go. Okay. There we go. So the blue ones are the ones where I win with. Oh no, the ones where you win with heads, tails, heads at the end there. And the red ones are the ones where I win with heads, tails at the end. Somebody in chat says they learned MATLAB today at work experience. Brilliant. This is in MATLAB as well. Can you put these in your personal statement? Right, you can talk about things you've done with MATLAB. Sounds fun. Okay, so 100 trials here. I've set this up correctly now, I think. So the blue ones are where you win with heads, tails, heads at the end. And the red ones are the ones where the computer flipped some coins and ended up with heads, tails. And I did this 100 times in my computer. And quite a lot of them are blue, but only 41 of them overall. We can do this sort of again if you like. There we go. So here it goes, generating another 100 random ways the game could go. And this time, a little bit worse, you only won 35 of these games, and I won 65 of these. So slightly wonky code aside, we can play this game again. I think I'll be nice. I'll let you choose again which one you want. Out of the 8 possibilities. So let's go back over here and let's redo this, but your sequence is going to be different this time. Okay, so I just need to switch on the poll so you can have a look at this. How do I do that? Like this? No. Ha ha ha. OVFox. There we go. Okay, your choice again. We just saw that if you go for heads, tails, heads, I'll pick heads, tails. And in the computer simulations, that seems to win about 65% of the time for me. You should maybe be a little bit suspicious that I've written some computer code that lets me test out some possibilities. I've tried out some possibilities about what to do here. Chat is now voting again on what to do. I'm going to suggest, you might be wondering what happens. I'm going to suggest don't pick heads, tails, heads again. Nobody's gone for that one. Also, maybe you can already tell what I'll do if you pick tails, heads, tails, THT. If you pick tails, heads, tails, maybe you can already see what I'll do in that case and what might happen. That's a little bit tricky, I suppose. And let's point at some things again. So last time you went heads, tails, heads, and I beat it with this. Turns out this is better. This wins. This time, if you pick tails, heads, tails, there's something I can do that's similar to this. But that's not what chat's gone for. Chat's gone for something completely different, which is tails, tails, heads this time. Okay, so you tails, tails, heads. And I am, this time, I'm going to go for, what am I going to go for? My word, heads, tails, tails, I think. So you might like to think about the, how long this is going to take, who's going to come out on top, and things like that. Come on, I want chat back now. There we go. Can I get chat back? No, there we go. The condition to win is we're going to flip the coin until a consecutive sequence of 3 coin flips matches one of these sequences. So like in my code examples here, sorry, the text is very small, but it keeps flipping heads, 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 tails, tails, heads, 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 tails, 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 heads, tails, heads, and it notices at the end there's a string heads, tails, heads, which was what you were looking for last time. Right, okay, your turn. Chat wants to really switch to tails, heads, tails. Okay, chat, if you do tails, heads, tails, it's very similar to what you tried last time, tails, heads, tails. I'll pick tails, tails, heads, and that's the same thing but with all the heads and tails flipped. Flipped as in swapped. So it's, if you try tails, heads, tails, I'll try tails, tails, head. Sort of by the same logic, which we haven't talked about yet, but by the same logic that ends up winning about 65% of the time. Okay. The fact that the specific sequence, so somebody's already suspicious, right, of my code, and you should be suspicious of my ability to win instantly on the first one, which I enjoyed a lot, and you should be suspicious of my random code as well. Somebody says the fact that a specific sequence wins more time than another sequence, doesn't that mean it's not totally random? Isn't this a bit weird? And it is a bit weird. The sequences, they're the same length, they're both heads and tails. The ones we had before had the same number of heads and tails in the sequence of length 3, but when we ran the code, we found that one of them came up before the other one, about 2/3 of the time. There's something going on there, that the outcomes are not independent, they're dependent, and they're linked. The sets of consecutive 3 outcomes overlap. So whether one of them or not is your sequence is related to whether an earlier one was my sequence. So the events are not independent. In fact, once we've gone through some examples and we've got some more clarity on what's going on here, this is going to turn out to be a good way to think about events that are not independent. Most of the probability things you do in school, you talk about independent events. Here, the events are very much not independent. Okay, have people worked out what I'm doing here? It's a little bit similar, isn't it? It's a little bit similar. You're hoping for some tails to come up, and then heads afterwards. So you win, I suppose, if there's lots of tails, and then heads. But I win if there's heads and then lots of tails. Now those might sound quite similar, but actually my one is more likely to happen first. We're going to try some coin flips, and then we're going to talk about why. Okay. Are you just... Yeah, so in particular, this is true, I think. If there's a tail, then a head. Yeah, if there's a tail, then a head, I think I will win, sort of, eventually. Let's try it out. Ah, good, that is a tail. Okay, this is a good start for you. Okay, so we saw tail. Good, I like it when it goes towards you, because I would quite like you to actually win a game at some point. Oh, there we go, tail. This is looking really good for you. Do you just win now? I think you just win now, right? We get 2 tails, then I keep flipping tails, but eventually I'll flip heads. And after I flip heads, okay, this is you win. Well done, chat. Let's play again. It's probability. Is the code just circular? So the question about shifting the code circular, I don't... Oh, shifting your code. Oh, am I doing something to your... Interesting idea. Okay. New sequence is coming. Here we go. Heads. I sort of know what you mean about shifting a code circular. It's not actually quite how I'm thinking about it. Oh, now I've got to heads, heads, and somebody told me that I win now, because after heads, heads, what am I going to do? Flip more heads? No, I'm going to flip tails. These are the shortest games ever. Okay, 1-1. Trying to make it not look rigged. Trying to make it not look rigged. Is it working? I wish I could rig coin flips. That would be amazing, wouldn't it? That would be a really good skill. Right, tails, heads. This is a slightly different case. We haven't had this one yet, has it? Have we? So if we get tails then heads, neither of us actually wanted tails then heads. You see? So the tails was good for you, but then heads, that's not what you were looking for. I did not win. Oh no, I did not win! I did not win. You're right. That is rigged. That is cheating. I did not ring because I went for heads, tails, tails. Whoops! Right, backing up, back up. Don't get away with that, do I? So heads afterwards. Will be short games if I declare them to be over before they're over. Oh my word, chat, are you back in this? I think you're back in this. I've got to heads, tails now. I've got part of the way through what I want. You've got part of the way through what you want. Coin flip. Heads again. Oh, heads again. This is pretty bad for me because now we're at tails, heads. Actually, heads is bad for you as well, isn't it? And then tails. Oh my word. I did not win, yeah, that's pretty embarrassing. Getting the win before I'd won. Heads. This period of getting heads, we've now got heads and tails alternating in a row for quite a while. Which is a bit keeping the game going, isn't it? Heads, 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 heads. Let's heads, heads, tails again, so I've once again not won. Got to pay attention, haven't we? Chat doesn't miss anything. Chat doesn't miss anything. But now it's heads, tails, tails. And now I have one. Okay, and that time for real. Woo! You can do it so you spin coins. I promise I'm not doing that. I think I've heard that you can get coins to spin. Yeah, I've heard this too. So you get them to spin so they're just wobbling and they look like they're flipping. I am not skillful enough to do that. There's also a trick I've heard about where you look at the coin when it lands and decide whether or not to flip it over as you move it from one hand to the other. I don't know how to do that one either. Yeah, right, cool. Don't play this game against somebody who knows how to cheat. Yeah, it feels like randomly creating a binary number and then finding the probability of getting a specific sequence of 1 or 0 in the generated number. So this is a good way of thinking about it, generating random numbers. They've said pseudo-random number generator, which I took personally, right? I'm a very random number generator. It's not fixed at all. So pseudo-random number generator. Oh no, hang on. That was two comments merged together. Okay, randomly creating a binary number and then try and find the probability that there's a specific sequence. Of course, if you keep generating the binary number, then eventually you're probably going to get both sequences. The question is which one comes up first. Okay, so let's try and do some analysis. James' last two letters are the same as chat's first two, but I put heads before, so either those two tails come at the start, or is the heads, James must win. Yeah, okay, so that's a way to look at it. So I look at maybe I'm looking at your two heads, those are the two tails that you're waiting for. You're waiting to get tails, tails, and I'm saying, well, maybe there's a string of tails that comes up. If there's a string of tails, then you'll win. Lots and lots of tails in a row. You'll win because either it keeps going with more and more tails, tension builds, or you'll hit heads. But I can get in the way of that if I pick this heads just before a string of tails, because then, in the case that there's going to be a very long string of tails, I've already won, because provided there was something beforehand, before that long string of tails. So this takes something you're hoping for, a long string of tails, followed by heads, and it gets me in first to say if there's going to be a very long string of tails, then provided there was something to the left of that, I've already won. So people in chat, unless we win the first three, then you always win? I think that is true, sorry, yes. So I think it's pretty unfair for this one, isn't it? Let's try it out with some simulations. So chat here reckons there's a probability that they maybe win in the first three, so 1/8 probability to win, or lots of other stuff, or the other one. Oh yeah, hi, good. Hello to anyone new. Is it always like this? Goodness knows. Right, okay, let's run some code again. So I've got to remember to change the code, because this time you're looking for, I feel like I've got a probability idea now, that maybe you win 1/8 of the time. Which feels bad, because about 40% of you voted for this one. I feel bad for you, right? Okay, so then I'll rotate, so I'll do that one. Okay, good. Right, here are the sequences, let's go. 100 games, please. Good. Okay, so the blue ones are the ones where, oh no, they're not on screen. Cut. There we go. The blue ones are the ones where you win with tails, tails, heads, and the red ones now are the ones where I win with heads, tails, tails. Have I got that the right way around? No, I've not got that the right way around. What have I done? Tails, tails, heads. I've really confused myself now. Have I got the counts right? Yeah, okay. Yeah, I think you win. I think you've won 23 games here. I can see loads of them on the screen though. Where are these red ones? I've confused myself about how my code works here. Heads, tails, tails. 1, 2, 3. I think the counting's gone a bit wrong. Maybe you won loads of these. Let's think. Has my code gone wrong? Tails, tails, heads, and these ones are rolling heads, tails, tails. Yeah, okay. Could it be a very long, so it's not just the first 3, somebody else reckons. Not just the first 3, because there could be a really long string of tails and then heads. That's true. You don't have to win in 3. You can win in... What is going on with these? I've not coded this up right for this one, have I? What is going on? Why is this one not stopped? Okay, my code has gone a little bit wrong. We're going to very quickly debug James's code. What's going on? Why has it done that? That first one says tails, tails, head, tails, tails. Yep, don't know what my code's doing anymore. I've lost track of what my code's doing. It doesn't seem to be stopping correctly. It's supposed to be stopping if it gets a heads, tails, tails, or a tails, tails, heads. If I just typed it in wrong. Has it always been wrong? Was it wrong for the previous one? Oh, Alfie's run some code as well in chat. Let's look at Alfie's code instead. Let's stop looking at my code. Maybe that's a good time to do some statistics on this, to do some probability. Are they written backwards? Have I maybe written them backwards? No, I don't think so. I think it was just broken. Right. Homework, write better code than me. Let's do a little bit of analysis. Somebody's worked out, I think in chat, and I quite like this, that if you get lots of tails at the start, then eventually you will win, in this particular case. But if there's a heads in the first 2 flips, then I think I will win, because now eventually there'll be some heads for a bit, and then maybe some tails. Doesn't sound very convincing. If there was ever going to be 2 tails later on, there's some heads to the left. So within those first 2, which I think makes it 3/4, 1/4, or is it even 1/4? Let's think. 1/4. So if the first 2 are tails, tails, then what's going to happen next, I suppose, either we get to tails, 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 or we get to tails, tails, heads. I see, so you win here, or if it's tails, 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 then only the last 2 kind of matter for the next thing that might happen. So the next sequence is going to start from sort of here, and it's going to involve something else. So it's going to be either tails, tails, tails again, or yeah, you win all of these, don't you? Hello, so we're playing a coin flipping game. Yes, thank you Prisma for the recap. Each of us are picking a sequence of things with 3 things in, and we're going to see what happens. Okay, so let's do some more theory on this. Some people reckon I'm just rotating your sequence, which is not quite what I'm doing. For example, if you pick heads, 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 then I pick tails, heads, heads. Okay, do you want to analyse that one for me? And jumping ahead a little bit, the game's not totally fair in some sense. Whatever you pick, there is something that I can pick that beats the thing you picked. We're going to talk about that over the next 15-20 minutes or so. And I'm just going to look at a very quick YouTube error message. Oh, thank you, YouTube. Good. Yeah, and here's a chat thing. There's a weird circular probability thing going on. It's a bit like rock, paper, scissors. Somebody said they saw it on TikTok as presented like rock, paper, scissors. It's a bit like rock, paper, scissors. The game here, I think now, is going to be to find out where is it like rock, paper, scissors, and how is it like rock, paper, scissors. Oh, thanks. That summary from Prisma in chat was really good. Thanks, Prisma. Good. Okay, let's see. So if you pick heads, 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 I'm going to pick tails, heads, heads. Yeah, and I'm just going to win, unless it starts with, if it starts with H and you get loads of 3 heads straight away in a row, but anything else, seems as his tail, I think it's all over for you, because how are you going to get those 3 heads in a row? Good. Okay, how are you going to get those 3 heads in a row? Well, the 3 heads will be preceded by something, maybe more heads? No, because then you'd have already have won if there was another head to the left, and obviously a tails to the left. So that would be me winning early on. Right. Yeah, so here's a quick cycle if you want to play this. Here's the cycle. Let's see. What have we found out so far? So I hope I've convinced you now that tails, heads, heads beats heads, heads, heads. Because the only way heads, heads, heads can win this matchup is to just get the 3 heads out of the gate, 3 heads straight away, which is it's actually not a very good matchup at all for the heads and tails, for the 3 heads straight off. It's pretty bad. You have to get those 3 heads straight away. So okay, so we've got one matchup here, and I think I convinced you that, or did I convince you this, that heads, tails, tails beats tails, tails, heads. And earlier on, we didn't really talk about it, but I think heads, heads, tails beats heads, tails, heads. There are 64 possible matchups, because there are 8 things you could pick and 8 things that I could pick. So a kind of homework exercise, if you want to explore all of the matchups, work out what's going on in all 64 cases. My word, that's a lot of stuff. Actually, it's not quite 64 matchups, because some of the matches you can swap them around for who's playing what, so you don't have to check those ones. And some of them you can switch heads, and you can switch the roles of heads and tails, so you don't have to check that matchup either. Pick the opposite to chat's first choice, then follow with chat's first and second choices. I think that works well. That's a good strategy, I think, in chat. It's a good theory. Does that always work? There are 8 things to check to make sure that always works. I could pick the same things. If we pick the same things, then we're going to draw. So I've been cunning and I've picked something different that is likely to come up before your choice. And it's a bit weird. I can do that whatever you pick. Here's why. Let's try and draw a sort of diagram. I think exploring some of this for yourself is quite good fun, because it is a little bit confusing how there isn't one best sequence. To start off with, maybe it doesn't feel like there should be a best sequence, because all the sequences should be the same. And then you find out that some of the sequences beat the others. So then you try and find the best sequence. And if you go and explore this, then you'll find that actually, no, there's no best sequence. Heads, heads, tails beats heads, tails, tails. But heads, tails, tails beats... that beats tails, tails, heads. Tails, tails, heads, it turns out, beats tails, heads, heads. And tails, heads, heads beats heads, heads, tails. Okay, this is part of a diagram of what beats what. But this is the kind of exciting bit where there's this cycle, like rock, paper, scissors, but with 4 things. Yeah. I wouldn't say I can always win, because sometimes you make a choice, and then I make a choice, and then your flips just come up straight away. And that happened in one of our games. But sometimes the thing, yeah, sometimes, what do I want to say? Whatever you pick, there's something I can pick that's more likely, that will win more of the games, like how we've been playing 100 games or something. I think I've worked out what my code's displaying wrong. Let's have a quick look. I've got an idea about what it's displaying incorrectly. It's adding 2. No, that's correct. It should be doing the min. There we go. I fixed my code. It was displaying too many. It was the logic was correct, but it was displaying too many flips. Okay, fixed it, because it was waiting until both had come up and then displaying that one, so it was very confusing. Min instead of a max. Yeah, that's much better. That's much better. Okay. Debugging code. Look. It's more obvious that I win all the games now. That's all I wanted. Yeah, it's kind of like rock, paper, scissors. Get right. Debugging code. Arguably, we'd moved on from the code now, and I didn't need to go and debug it, but you know, it's going to play on my mind otherwise. Yeah, it's like rock, paper, scissors. This diagram, note, I have left you some homework to try out for yourself. Those diagrams only got 4 of the things on. I haven't proved anything, I haven't told you why. I'm going to equip you now to try and prove some of these things, to work out why some things beat other things. And then homework is to, I suppose, go and put in other things into the diagram so that you can keep track of what beats what for the... There are 4 things hidden not in this diagram at the moment, because we agreed at the start there are 8 possibilities. I'm saying homework, I should be clear that it's not actually homework. You don't have to hand it in, nothing's getting marked, nobody's going to give you any grades. It's not like school. It's a suggestion for something you could try. Cool, okay. I am going to show you a way that you can analyse why one thing beats another. First, I'd like to think about, let's talk about that instead of, that's very brilliant, I like that. Pokemon, instead of talking about rock, paper, scissors. Who plays rock, paper, scissors? Nobody, but Pokemon, yeah, everyone. Right, good. Here's a trick for analysing this. I'd like to start by thinking about what happens if there aren't any winning combinations, we just keep playing forever. And I'm going to draw a different diagram. Just going to grab some more paper. This is the joy of being in the office. There's all this stuff ever. What's the two? Oh, look at that. What's the 2 sequences with the largest win-lose difference? I think it might be... Well, we're going to find out. That's a good question. That's a very sort of mathematician question, actually. To say, well, look at, we could do all these 64 calculations for the competitions, but then also go back and look at your numbers and work out which one's the most imbalanced. What was I hoping you would pick? Because I could pick something way better. I like that. Okay, other remix questions that people want to tack on as well? Once we've analysed everything, what questions do you want to ask? If you had code that could run it for 100 times, 1,000 times or something, I think Alfie wrote some code that was running it 100,000 times, what other questions would you ask? I put one earlier on, how long does it take before the game ends? Because some games take ages and some games are quite quick. That's a really hard question that you could maybe experiment around with by writing some code, or even theoretically with probabilities. And somebody else here has asked what ends up being the biggest discrepancy. Cool, right. So normal play, let's say if there are no winning conditions, we keep flipping the coins. It's very mean to my computer to get to keep flipping coins. Very mean on my thumbs to get me to keep flipping coins. Here's what's happening looking at the most recent 2. This is my title of my graph here is most recent 2 flips. And it's the most recent 2 flips that matter, because maybe the game's over and somebody's won, or the next flip is the one we're waiting for to see, is somebody going to win now? Ooh, yeah. Prisoner's trying to answer the question as well. Good. Yes, perfect. Does the win-lose number change if the sequence goes from 3 parts to 4 parts to 2 parts? Yeah, play this game, but I've made you choose a sequence of length 3 and I chose a sequence of length 3. What if we did 4 instead? Okay. So what could happen in this game? I'm going to draw some arrows between these different states, the different statuses for what the game could be. Longer strings, higher base than binary. Already thinking about it like binary, that's good. Yeah, so what if the coin's got 3 sides? Who knows? Right, oh wow, I hadn't thought of that. That's very exciting. Okay, I've got to not think about, this is the challenge. People are putting interesting questions in chat. I've got to not think about them and show you this diagram. So what could happen? If we've got heads as the two most recent flips, then we flip another coin and we either get heads again, in which case the 2 most recent flips are still heads and heads, or we get tails, in which case now the 2 most recent flips are heads and tails, like that. Okay, so is that, I flip a new coin and I look at what are the most recent 2 flips now. Okay, on the other hand, if the 2 most recent flips were tails and heads, then when I flip a new coin, I might get heads, in which case the 2 most recent flips are heads, or I might get tails, in which case the 2 most recent flips are heads, tails. Okay, and over here, if I've got heads, tails as my 2 most recent flips, then I might get tails for the next one, and I might get, or I might get heads for the next one, which will take me over here, and tails has this loops around because I might flip tails, or I might flip heads and go over here. Okay, so this is the sort of normal status. If you flip coins and look at the 2 most recent flips, then you move around this diagram. So maybe you flip heads, tails, tails, heads, tails, heads, 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 or something like that. You move around this diagram. I think it's kind of interesting, that there are 4 nodes on this graph, but they're not all treated equally. There's some sort of symmetries going on, but maybe not as many symmetries as you would guess before I started drawing the arrows in, right? For what happens when you flip a coin. Those 4 states aren't equal somehow in the way they relate to each other. And it's exploiting this that lets us find winning strategies for when one sequence beats another. Okay. Yeah, so people are putting Markov chains in chat. I'm going to say 2 things. If you haven't heard about Markov chains, then here's a great introduction to what a Markov chain is. Markov is somebody's name, and the idea is that you're moving around from state to state, bouncing around, moving around from state to state. There are some probabilities that you move from one state to another state. Here all the probabilities are 1/2, so I haven't labelled them, but the idea for Markov chains is you're moving around from states, bouncing around like this, and thinking about what state something's in and probabilities to move to different states is a good way of thinking about lots of problems. The study's called Markov chains. If you haven't seen Markov chains before, here's a Markov chain. If you have seen Markov chains before, then I think maybe you should have said Markov chains earlier, because thinking about states like this, once you know about Markov chains, part of the fun is that you can spot them in lots of different places. That only the 2 most recent coin flips matter. There are only really 4 states, and we think about probabilities for moving around. Here's how the game works. You pick an outcome, and then I pick a different outcome. So let's say you picked heads, heads, tails. Let's think. So heads, heads, tails would be putting a sort of interception point over here, so that if we had heads, heads, and then got tails, then heads, heads, tails would winning would be over here. That's sort of what this arrow means, that we had heads, heads, and then we got heads, heads, tails. Okay, that's how heads, heads, tails wins. We were in state heads, heads, and we flipped tails. So instead of going to heads, tails state, heads, heads, tails wins and the game ends. Okay, so let's say you pick that arrow as being the one that is interesting to you. Then during normal play, as things come up, the first 2 flips put us on one of these states, and then we move around following the arrows. Either we get tails or we get heads. So we start in one of these. You would obviously like it if we started in this one at the top, because if we start in this one at the top, then what happens next from the top? Either you win going through here, or you loop round. But look at the arrows. There's no way to go to anywhere else, so we're going to keep looping around and go over here. I like these diagrams because they take something that's quite hard to say in words, saying heads and tails and moving, and they turn it into quite a visual thing about moving around, where you can see from the arrows that if we happen to start up here, then by the arrows there's no way to go anywhere else other than this win. And also we can see that if you start here, things are looking quite good for you. Because maybe we'll go up here and then we'll loop around and go over here. Okay. So what I can do is I can pick this arrow to be mine. That corresponds to tails, heads, heads. Okay, and this sort of cuts you off. I can declare this arrow, the one that corresponds to tails, heads, heads, to be mine, the one that causes me to win. That sort of cuts you off because now, it's brilliant if you start at the top of the diagram, but if you start anywhere else, then, oh no, there's loads of stuff going on down here with things bouncing around, but there's no way to get to your red winning arrow without first going up to here. Yeah, so really good question from Alfie. Let's do Alfie's question, then Kai's question. So Alfie says, does the loop at the top also mean a heads, heads, heads wins? No, so it kind of means that heads has come up again, so there's more heads. I suppose it corresponds to, okay, so yes, if you picked heads, heads, heads win, then this is the arrow that you've picked. The arrows correspond, I suppose, to the 8 sequences of three symbols long. So that loop at the top is the heads, heads, heads win condition, where you had heads, heads, and then you flip another heads up here. There's another case where you'd be hoping to be up at the top. In that case, I would also pick this green arrow over here, because it cuts you off again. You're hoping to be up here, looping around, getting heads, heads, heads maybe. But if I pick this arrow over here, then, oh dear, wherever else we are in this diagram, moving around, doesn't really matter because eventually we're going to end up moving through here before we do the heads sweep or the heads tail win over here. So if you pick one of these two arrows to be yours, I'm going to pick this one over here. Okay, so that's one thing. Right, let's do Kai's question. Do you want to pick a state that appears directly before the one the other person has chosen? Sort of. We've got to define before quite carefully. If you pick this one, then this one I think is good, and there's something else going on around the other side of the diagram, but the diagram's not quite rotationally symmetric, so it's not quite clear what before means in the other case. I'm going to show you that picture next, I think. So I'm going to do a new version of this picture. This is how you beat someone who's picked an arrow coming out of heads. Similarly, if somebody picks an arrow coming out of tails, you cut them off by picking this arrow. Let's do another version of this diagram. Let's see if I can really quickly redraw this diagram to talk about the other case, which is a little bit more interesting. Everything's interesting. Something's more interesting than others. Casey asks, is the best winning strategy one that tries to avoid the infinite loops at the top? Well, let's see. Let's do that one now. I think this is the time to do that one. So let's say you've seen that and you've picked instead this arrow over here. This is going to be yours. Now, similarly, there's some stuff going on in the middle there. What you're hoping for, I suppose, is to get tails heads to come up and then to win by flipping that heads. And now it's looking quite good because even if you don't see that, then you might bounce around here a bit and come back in again. So the strategy in this case, if you pick that, yeah, each state has 2 arrows coming in and 2 arrows coming out. That is true. The 2 arrows coming out are because there are 2 things that could happen next. The 2 arrows coming in, you fill in the gap. Okay, the strategy here, maybe Kai will say that this is picking the one before. The strategy here is to pick this one. Kai, is that what you meant by before? To go kind of around. Maybe I made a big deal out of the thing not being rotationally symmetric, and now look, the strategy is sort of rotation based. So now it's a little bit more complicated to analyse why the green tails heads win is better. And it's sort of because of the inevitability from the tails and the way that if you start anywhere else, you could maybe end up at tails. We can do better than that though. Yes, there we go. We can do better than that though. Of course, we're mathematicians, we can put some numbers on that. Let's talk about 2 numbers. So if tails comes up, then obviously green's going to win. We're going to loop around getting more tails for a bit, but eventually we'll get heads and we'll leave out this way. So there's 2 things we might be interested in. We might be interested in the probability of a tails heads win, given that we're currently looking at tails heads over here. And we might be interested in the probability of a tails heads win, given that we're currently over at heads tails on this side. So this vertical line is short for given that, or in the case that is already true that we're at something else. Why not pick heads tails heads? Pick one of those ones instead of one of those ones. Well, maybe homework. Go and find out. Go and find out if that works as well. Okay, I'm going to call this one P1. And I'm going to call this one P2 for these two probabilities that I'm interested in. I'm interested in them because they're related to your probability of actually winning. Here's what happens. So P1, the probability that you win, if we're currently looking at tails heads and about to flip another coin, well, maybe we flip heads and you win. That's pretty good. And also you get an out if we flip tails, because then we go over here. And now we're looking at heads tails, and the probability you win now, I don't know it, I suppose, but we've given it a name. That's P2. So P1 is 1/2 plus P2. Yeah, I think Markov chains are probably in the CS course somewhere. I'm not sure. Yeah, or do you think they're equal to each other? Well, no, this one P1's a little bit bigger because if you're in tails heads, it's going really well for you, and your red's about to win. This one's quite far away, which we're going to work out now. So P1 is 1/2 plus, if that doesn't work, also that should be 1/2 of P2. Sorry, second major mistake of the day. 1/2 of P2, because 1/2 we need the probability that you flip a tails and then the probability that you win from there. Multiplied together. Those things happen. Okay. Whoa, that was pretty bad. I hope I get away with that. P2, the probability that you win from over here, well, something very particular needs to happen. You need to flip a heads, and then you need to win from there. So that's 1/2 times P1. And you don't win at all if the next flip is tails, because we come over here, and then green wins over here. Okay, so I'm looking in each case there, I'm looking at if we're at one state, two things might happen next. What does that mean for your chances? 1/2 probability the first thing happens, 1/2 probability the second thing happens. What are those? And hopefully, if I've got these right, we've now got some simultaneous equations. We're pretty good at simultaneous equations. You can go rearrange these to find that P1 is, let's plug this in here, so this is 1/4 P1 if I plug it in, subtract it, 3/4 P1 is 1/2, multiplied by 4/3 to get 2/3, and P2 is then 1/3. Okay. Right, let's put all that together. So P1 is 2/3, P2 is 1/3. You're a bit more likely to win if we're here. The initial place we start, where did we start? We started in one of these 4 states at random, because those are the first 2 flips, and then we start moving around. Yeah, those are consistent. I think we're fine. We started in one of these states at random. If we start in tails, tails, then it's terrible. Red doesn't win at all. If we start in heads, tails, that's got probability 1/4 that we start in heads, tails, and then probability P2 to win from there eventually. And there's a 1/4 chance that we start off with tails, heads as the first 2 flips, and then there's the probability is P1 that you win from there. We also start, there's probability that the first 2 flips are heads, heads, in which case eventually we'll get around to heads, tails over here. So there's an extra 1/4 chance times then P2, the chance that you win from there over there. And that all adds up to 1/6 plus another 1/6 is 1/3. So there's some analysis to say, 1/3 at the bottom there, to say that for this combination, it's not as clear cut, but the chance that red eventually wins, given the 4 possible starting places, which are equally likely to start off with, works out to be 1/3. You have to do a little bit of algebra to work out what's going on in the middle there, and you have to do a bit of considering all the possible starting points. Good, okay. So you can analyse other combinations like this. If you prefer, you can write out some sort of sequences for what's going on. There's these infinite loops at the top and infinite loops at the bottom, but there are also infinite loops in the middle going on. So you can write out some sort of infinite things with geometric series. Yeah, they are consistent. The whiteboard behind me is quite humorous. The whiteboard behind me is a big plan that we wrote up for maths event. We wrote it up just before the pandemic, and it's got somewhere on it, it's got online. Online is one of the categories. We've just had this idea, maybe we'll do some stuff online, and then the pandemic happened, and we started a maths club. And now we're doing loads of stuff online. I don't think it's confidential. Good, right. Maybe I should put, I'd have put something really funny on the whiteboard behind me, like a QR code for a Rickroll or something amazing like that. Good, right, okay. Other analysis is available. I'm really interested, somebody in chat said, what if there's more outcomes on the coins? That's something that I can go and put into my code, of course, or you could write code to try out. Different length sequences, can we find any cool rock, paper, scissors like structures out there? Yeah, other versions of this problem are available. Yeah, the whiteboard literally says online, underlined, Mat Prep support, which then turned into Mat Livestream, which turned into Math Club. So this is the sequence of things that have come out of this office, and now for the first time, coming out of this office live. Right, good, okay. I mentioned cards as well. I'm not going to really do this a service, but ages ago I mentioned a problem to do with drawing cards on the live stream, and I got an email back. I got a really nice email that I'm going to load up. I'm not going to show it, don't worry, but I got a really nice email from Ali telling me that a problem I described as really hard, they'd solved. So I always like that sort of email, right? I said on the live stream that a problem was really hard. Somebody writes into me to say, here's the solution, mate. Here's the numbers. Am I right? And they are right. It's brilliant. So I sort of wanted to talk about the problem and their solution to it. I've only got 5 minutes, so we're going to do this a little bit quickly. Sorry, Ali. We're going to do a real rushed version of some great maths that Ali sent me. So different problem. This is the cards problem that I said we were going to do at some point. Change the coins into cards and make the heads and tails into 4 houses. Yeah, I love it. 4 outcomes. Maximum length of the sequence is 52, but you stop after 52. Are you looking for a sequence of 1 card or a sequence of 2 cards? I don't think about sequences of 2 cards. Yeah, I think there's versions of this game as well where you've got 4 possible. Okay, so this is not binary, not trinary. This is fornary. What's that called then? Quadrinary? Double binary? Binary plus? Anyway, 4 possible outcomes and looking for sequences of cards. Who knows? Right, okay, card problem. Sorry, Ali. Is Ali in chat? I don't know if Ali's here. There was at least 2 Alis around earlier on. I don't know if they're still watching. So the card problem was this. You draw 5 cards from a deck of 52. That 52 is made up of 13 values times 4 suits. I want the probability of a pair to the same value. So 13 values. I won't list them all. Ace, Jack, Queen, King, and 2 to 10 for some reason. And there are 4 suits. This just looks for probability of a pair when you draw these 5 cards. You draw them without replacement. And I said on the live stream that this problem is really, really hard. I was imagining all the different combinations that you could get of picking things up. Ali is here. Hi, Ali. We're doing this. So I said this is really, really hard, but Ali pointed out that there's a good trick that you can think about this as 1 minus the probability of no pairs. And if you think of it as the probability of no pairs, that's a better thing to be thinking about, because the probability of no pairs you can track through as I draw the cards. If I want no pairs, then I can talk about the probabilities that are coming up. So Ali sent me this great email to work through the possibilities of what's going on there. This probability is something like, let's really cheekily load the email up so I get this right. So to start off with, there are 52 cards that you could get for the first thing. That's fine. No pairs yet. We're all fine. But then for your second draw, there are 51 cards left over, and you want to ban all of the ones that are the suit. All the ones that are the same value that you already have in your hand. Maybe you've drawn an ace and you want no more aces, and there are 4 aces, so subtract those. There are 48 acceptable cards for that one over there. And then the next draw, there are 50 cards left in the deck, and I'm now holding, if things are going well, an ace and 2 or something like that. And now I want to ban all the aces and 2s or whatever they are, and just look at the remaining cards over there, of which there are 44 that don't match. And then there's this lovely pattern that falls out here as you keep going, to say that you want to keep going. As you draw cards, there are fewer in the deck, and you're ruling out entire values as you go along, so the top goes down by 4 each time. This is a big fraction. We can work it out if we want to, and in fact Ali did in this email. It turns out to be 2053 divided by 4165, which is one of the best numbers I've ever got in an email. I love the way it's really close to the number 1/2. It's almost 50-50. Feels like a fact that I should have known before I said that it was incredibly difficult on the live stream. It's very good. Well done, Ali. I love the way as well that as soon as you see this, it's the solution to several related problems as well, right? We've been talking a lot this term about taking a problem and adapting it. Yeah, and this is taking the thing like the birthday paradox. Like the birthday paradox, that's the episode it's from. The birthday paradox thinks about flipping it as 1 minus, and then think about the possibilities of no shared birthdays. with multiplication signs there, Casey. This is very similar, but it also answers, you know, a variety of problems. This term we've been thinking about remixing problems and coming up with different versions. This, just by writing out the nice pattern, you can already see what happens if we have a different deck of cards, some weird deck of cards with different number here and a different number here. It's pretty clear what's going on for just different numbers going in, because the pattern's so clear in this way of laying it out. Okay, if you send in maths to the email address on the screen, then there's a chance we'll show it on the stream as well at some point. I'd be really interested if anybody worked out those drawings that we were doing for the last couple of episodes. If anybody had a go at those, I'd love to talk about those again. And if anybody does anything cool with the heads and tails, then let's see that. And then there's an attempt at some sort of formula with factorials and question marks. This is very confusing due to the question mark as well. I have a little running thing about chat. Sometimes chat, you just need to not put the question mark on. There's a confidence thing going on, I think. Derivation, time spent in a shadow of a planet by a satellite. Really satisfying and interesting graphically. Oh, is this the thing with a bumps at 0 and then the way it transits across? Yeah, we should look into this sort of thing. There's a lot of cool stuff going on with astronomy. Right, okay. I think we've reached the end of the hour. Thank you very much for watching. If you've enjoyed this, we're doing this every week at the moment. I'm actually still coding up a thing in Turtle. After the live stream finished, somebody did send me their implementation of the dogs chasing each other code, which I haven't run yet. Okay, good, right. Have a nice week, everyone. Take care. From everyone in Oxford in the new studio. It's just me in the studio. The studio is my office. I think we made that clear, James. Right, have a great time, and I'll see you around. Bye.